In science, no theory is immune from one day being overturned, even if it has been integral for a very long time. Isaac Newton, for example, first theorized the existence of something called ether, a seemingly magical substance that Newton suggested was what filled the emptiness of space, giving waves, including light, a medium to travel through. And the idea largely held for hundreds of years thereafter, until one Albert Einstein finally explained ether away. A one-time pillar of science had been knocked down and reimagined. But now, fast forward to today, and could something similar be happening all over again? There are many theories in science that we think are mostly right, but not quite perfect. Einstein's theory of general relativity, for instance, is held to be one of the most ingenious out there, but we know it's incomplete. Although it explains a huge amount about gravity and space, it still falls short regarding quantum gravity and singularities, like those that form in the center of black holes. The same can be said about the standard model of particle physics, that it's good, but not quite perfect. It's the most successful framework we have to broadly describe the way our universe works, explaining how all particles link to four fundamental forces: the strong and weak nuclear force, the electromagnetic force, and gravity. The model pitches that these forces are what allow elements to form, and they dictate how particles interact. But the standard model also isn't complete, and science knows this. Despite it explaining three of those four forces extremely well, it has yet to effectively incorporate gravity. It also fails to allow for dark matter, to some degree antimatter, and other important unknowns in astronomy. One of the ways in which the standard model is continually tested is with the help of atom-smashing particle accelerators. These incredible machines, the most famous of which is the Large Hadron Collider beneath the France-Switzerland border in Europe, are used to accelerate beams of particles to intensely high speeds, sometimes getting close to the speed of light under routinely extreme conditions. In general, the matter within the accelerators is propelled to these speeds in order to achieve high-energy collisions, which smash apart protons, or whatever's being tested, into a cloud of different, often rarer, subatomic particles. For science, it's like breaking into the subatomic world. And by watching these interactions, researchers can test predictions and, hopefully in some cases, find new particles. In 2012, the famous detection of the elusive Higgs boson particle, said to be what gives mass to all other particles, was for a time thought to have rounded off the standard model, filling in the last great puzzle piece within it. But now, all confidence is out the window, as new research is threatening to totally upend the model, irrespective of the fact that it's been a cornerstone of modern science for decades. For the most part, the standard model has proven good at predicting things like particle mass, weight, and general behavior, but apparently not this time, after a discovery announced in April of 2022 regarding a particle called the W boson. W bosons are important in physics because scientists think that they, with the help of Z bosons, give rise to the weak nuclear force, the force responsible for radioactive decay in atoms. The paper detailing the discovery, published in the journal Science and relating to a decade-long study by a team at Fermilab in the US, found that the W boson in particular is slightly more massive than would be expected or predicted by the standard model, about 0.09% more massive. And while that may sound a little underwhelming, extreme precision is vitally important in subatomic study, and even the tiniest of variations can make or break a theory. And so, despite the discrepancy being small, the results are statistically significant, implying that something's gone awry. Either the method and measurement or the standard model itself is in error. Particle physics until this point, then, really could be thought of as wrong. This isn't the first time the W boson has been scrutinized. Researchers first found the boson and recorded its mass back in 1983, and at the time, the data matched what was expected of it. The particle was found to fit within the standard model. Times have changed, however, and the new boson measurement is the result of 10 years' worth of work and countless particle collision tests. In fact, those behind the 2022 study claim that the new measurement is more accurate than that obtained from all previous W boson experiments combined. And while 10 years of analysis toward one subatomic particle might feel like a lot, a member of the project, the physicist David Toback, has reportedly said, quote, "You can do it quickly, you can do it cheaply, or you can do it right," end quote, before claiming that they did it right. It would appear then that in this case, neither the method nor the measurement is at fault, which means only the standard model itself is left wanting. Due to its wide-reaching repercussions, this seemingly tiny W boson revelation has sent shockwaves through the scientific community. There have already been some theories put forward to try and explain the W boson's mass while preserving the Standard Model, including a suggestion that there could be a problem with how we understand that other poster particle of 21st century science, the Higgs boson. But so far, nothing sticks. To some degree, this could prove to be the first major blow to the Standard Model since its creation in the 1970s, although it should also be noted that not everyone is quick to completely write it off. At what's still an early stage in science's bid to process what has happened, many are taking the new boson results with a grain of salt, at least until they're confirmed by follow-up tests. A claim as heavy as this certainly requires a lot of investigation before it's universally accepted, and researchers, including those across the Atlantic at the LHC, are already working toward that. But it's expected to take time. W bosons are notoriously difficult particles to pin down for a couple of reasons. First, they rarely appear, with it reportedly taking literally millions of collisions during the Fermilab tests between protons and antiprotons to produce just one of them. But second, they're also extremely short-lived, disappearing before they can even be directly measured at all, as researchers usually have to chart them based on the energy trail that they leave behind. Really then, this story already represents an impressive enough breakthrough based just on the fact that science can now get any kind of handle on these things, when for so long they had been essentially inaccessible. But the discovered discrepancy on top of that makes it all the more important. So what happens next? Armed with and inspired by the new, ever so slightly more massive measurements, scientists will now strive to work out why the W boson doesn't fit with how we thought things should be. What specifically sets it apart? What specifically is lacking with our current model of particle physics? And what do we need to change to improve it? Because although research like this might at first feel like a disappointing result, and although it may make it appear as though science has failed us until this point, it's actually the opposite that's true. Thanks to improved study, we now know that there's more we don't know about the universe. And that paves the way towards opening new doors, bringing in fresh perspectives, and potentially gaining a better, truer grasp of reality than ever before. At the subatomic level, the present perhaps isn't quite what we had previously expected it to be, but the future remains bright. There's a fresh challenge laid out in front of us, and this new research might be exactly what science needs to progress. This one discrepancy could well force physics into developing a new standard model, which could fundamentally improve the base knowledge of our entire species. That's why this tiny measurement is also huge news, because of the wider implications that it could have, because of the changes it could trigger, and the answers it might reveal. What's your verdict? What does the W boson tell us about the wider world around us? Is the standard model still strong enough for purpose, or does this one hole weaken it beyond fixing? The debates are sure to rumble on, and the follow-up tests are already underway. But that's how scientists may have just discovered that particle physics is wrong. In our relentless pursuit for knowledge, there are some questions and mysteries that are much more difficult to decipher than others. And the question of death is arguably the most difficult of all. What really happens when the end comes? Can we ever be completely sure until we ourselves reach that point? These are problems that human beings have always wrestled with. But have we finally been given a glimpse of the truth? Unsurprisingly, there have been countless studies into death over the years, but also, and understandably, there are various ethical considerations which make the business of analyzing and measuring death a little tricky. Death comes to us all, but it's often unexpected. And even in a hospital setting, the focus at the moment of death is usually on trying to keep the dying person alive, rather than recording precisely how death unfolds for them. In February 2022, however, news broke of an accidental recording of a dying brain, which reportedly has given scientists a unique snapshot into a person's final moments. Although details of the recording were released in 2022, the event in question actually took place 6 years earlier in 2016. An 87-year-old patient in Canada was then being treated for epilepsy, which involved doctors taking brain scans to measure his neural activity. However, when the patient unfortunately suffered a heart attack and died during one such scan, it meant that researchers had captured a unique series of moments within his brain, before, during, and after death. With around 900 seconds of brain activity measured in total, analysts were subsequently able to specifically pinpoint 30 seconds before and 30 seconds after the patient passed away. And what they found appeared to support a long-held theory about dying, that your life flashes before your eyes. According to the study, published in the journal Frontiers in Aging Neuroscience, the dying brain showed an increase in gamma activity, releasing brain waves that are ordinarily linked to memory recall. The patterns that were recorded also relate to complex functions such as dreaming and meditation. The suggestion is then that when death arrives, the brain perhaps does embark on the phenomenon sometimes known as life recall. And in the case of this particular patient, it may last for up to 30 seconds after the heart stops beating. Up until now, most of what's known about this comes from the testament of those who have had a near-death experience. The sensation of having revisited key moments from their lives is one of the most often reported by anyone describing an NDE. Scientists have also seen similar gamma surges in the brains of dying animals such as rats during testing. But this latest study offers a unique look at what happens to the human brain. Importantly, those behind the findings highlight that this is still just one case study, and so the results can't yet be applied to every brain. The patient had been diagnosed with epilepsy, which may have affected how his particular brain reacted to death. Similarly, the medications that he had previously taken might have had an effect too. And as no normal brain activity had been measured beforehand to serve as a comparison, it can't be clearly proven that any of the changes in the dying brain were that dramatically different to the patient's standard brain activity. As groundbreaking as this study appears to be then, there are still plenty of questions and mysteries left to be solved. But nevertheless, this study could yet serve as one of the most significant moments in our quest to understand the dying brain, and the human brain in general. For many, the 21st century is shaping up to be an incredibly important period for neuroscience. We've already made important breakthroughs regarding how we understand the senses and how we view the importance of sleep. And thanks to an ever-increasing mass of data, researchers can better than ever before map the brain and identify neurological processes. The human brain is still widely regarded as possibly the most complex single structure in the entire universe, but we've also never understood it quite as well as we do today. The Human Connectome Project, or HCP, is perhaps the most ambitious research initiative relating to the brain overall. A U.S. state-sponsored effort to map the human brain in its entirety, it was started in 2009, originally with a 5-year goal for completion. So massive has the task proven to be, however, that it still hasn't been finished, 13 years later in 2022. The scope of the HCP has grown and grown in that time, though, so that it's now a multifaceted international venture. For example, while part of the project aims to better understand how Alzheimer's disease and dementia take hold, another concentrates on anxiety disorders and how they can be identified by how the brain fires. There are also specific studies looking at the human brain at different points of its lifetime, from infancy through to old age. So while the 2022 Dying Brain study wasn't directly linked with the HCP, we can see how the results of it have hugely contributed to what's become an enormous field of research. But finally, what can we do with the information that the Dying Brain study has provided? Unlike with so many other areas, it's not as though scientists are expecting a wealth of new and supporting data to arrive anytime soon, due to the ethical considerations involved. A doctor can't just simply measure a patient's brain until they die without seriously neglecting their duty for care. And in fact, according to some reports, one of the reasons why it took until 2022 for details to be released of a brain recording from 2016 is because researchers have been trying to find another similar case in the meantime, but without any luck. This one glimpse of the dying brain is an exceptionally rare event then. And while we might expect more examples to emerge as technology improves and evolves, for now it has set something of a new precedent. Until now, the notion of a dying person's life flashing before their eyes has perhaps been treated somewhat skeptically. No matter how many near-death experiences are reported, the apparent similarities between them are often put down to things like stress of the event, misremembering, or confirmation bias. It's said that patients may recall certain aspects of an NDE only because that's what they had previously expected would happen during one. But now there appears to be genuine scientific findings to support the claims. The idea of life recall may no longer be so easily dismissed, as we now know that in at least this one case, The areas of the brain involved with memory recollection were particularly stimulated right at the end of life. Unfortunately, what this study cannot do is stop death in its tracks. The search for immortality goes on across all sectors of science and technology. But one consideration might be whether this latest development will lead to us managing death a little differently in the future. As the Human Connectome Project, amongst other things, seeks to better equip us to fight against various neurological conditions that can affect the human brain, if we're now getting a grip on the brain activity of death itself, then might we soon try to tackle that as well? If not to prevent it, then at least to ensure that when death does come, we can shape how it affects our final moments. Now, perhaps there is some comfort already to be found. Although this remains just one case study, and many of the conclusions to draw from it are still hypothetical, the suggestion is that when we leave this life, we do so in a dreamlike state of memory recall. For one patient, at least, the brain activity during death appeared to stimulate these kinds of reflective, recollective final thoughts. And that's why, to some extent, scientists might have discovered what happens when we die. Or at least they might have discovered a little bit more about one small part of it. But of course, there is still so much about dying that remains a mystery. And there are so many metaphysical questions about the soul, spirit, mind, and body that will continue to stoke debate. It's human nature to ponder our own mortality from time to time, and perhaps it's unsurprising that there have been various efforts made to beat death over the years. But equally, while all of that's happening, it's crucial to also make the most of life, to fully experience every moment as best we can. Because if the incredibly complex structure of the human brain tells us anything, it's that our lives are truly a unique and amazing opportunity. Alien life was once considered something of a taboo topic among mainstream scientists and academics. For a long time, any research into UFOs or into making contact with aliens was frowned upon and often declared pseudoscience. But not anymore. In the modern world, we have the US government releasing official reports about UFOs, we have plenty of cases from within the US military, and now even NASA is investigating. But might first contact have already happened? And did China beat America to the scoop? It didn't take long after the invention of radio for humans to wonder if the same tech could one day be used to make contact with things not of this Earth, extraterrestrials. Here was a technology capable of sending messages at light speed, even through the void of space. So the chances seemed good. One of the first to suggest an alien application for radio was the famed inventor Nikola Tesla, who reportedly questioned whether a souped-up version of his new wireless system might also be able to contact beings on Mars. Tesla was also among the first to claim that he'd received an alien message, believing that another civilization, again on Mars, had reached out to him via radio in 1899. Though there wasn't an official organization until the late 20th century, the experiences of Tesla and others go down as some of the earliest examples of SETI, the search for extraterrestrial intelligence. The formation of the SETI Institute came about in 1984 as the wider debate around the possibility of contacting alien life grew and grew. And really, since that time, SETI has mainly focused on the potential use of radio to this end. As we found in another recent video, some now believe that a search for extraterrestrial artifacts might be a better way forward. But radio remains our most widely used method regardless, continuing on a tradition of research that's been going for more than 100 years. When using radio transmissions for SETI, however, scientists must meticulously ensure that any signal they detect really is artificial rather than natural. And herein lies why it's proven so tricky to the point of impossible over the years to say that any one radio signal definitely has come from an alien group. There are so many objects in space that can and do produce radio waves all the time, such as pulsars, black holes, and even solar flares. Nevertheless, there have been some detections that have proven more interesting than others. Any discovered signals that are seemingly repetitive, for example, are more likely to warrant closer study. Among the technology that SETI turns to for that closer study are telescope arrays, like the Allen Telescope Array in California, which has cataloged hundreds of millions of signals over the course of its run, or the Serendip setup. the search for extraterrestrial radio emissions from nearby developed intelligent populations, which is also in California, and which has found hundreds of notably suspicious signals. Today, though, the focus is on China's 500-meter aperture spherical telescope, otherwise known as the FAST. The FAST was created with a main drive towards finding alien life, and according to some recent reports, as it completes its 6th year of full operations, it may have finally just done that. Headlines broke in June 2022, but the story goes a couple years further back. Dubbed China's Sky Eye, the FAST telescope detected a signal of note multiple times between the years 2019 and 2022. According to reports, the signal appears to be coming from the direction of a distant exoplanet named Kepler-438b, an Earth-like world orbiting around the red dwarf star Kepler-438, about 472 light-years away from us. The planet had already been deemed a promising candidate for alien life due to the distance between it and its home star, as well as some comfortably survivable average surface temperatures. But now, the signal coming out of Kepler-438b has been branded by researchers as a possible technosignature, to suggest that it might be the result of alien technology. The seeming regularity and repetition are key features, made even more intriguing because of where the signal originates from, specifically a potentially habitable planet. So how did the FAST hear it in the first place? Well, it's able to pick up signals from so far away due to its spectacular and specialist sensitivity, which is rated amongst the highest in the world. It's also the largest radio telescope in the world. It can then detect even the faintest radio signals that hit the Earth, and so it's a leading tool as we scour even the darkest depths of the universe for life. Nevertheless, those working on the data from FAST did caution against jumping to conclusions too soon. As with all signals that seemingly could have an artificial origin, this latest one still requires a lot of further testing. It could still be that there's a natural phenomenon that's causing it, or that there's some other type of interference happening. It certainly wouldn't be the first time that radio readings have been misinterpreted. Signals from the Parkes radio telescope in Australia were once notoriously mistaken as being potentially alien-made, when in fact they had been generated via microwave ovens within the Parkes facility itself. And in fact, this latest one from the FAST could yet be explained away much closer to home too. Such is the delicate nature of identifying these things, and the extreme sensitivity of FAST. Commentators have already highlighted how the signal could just as well have originated from Earth. It might appear as though it's coming direct from Kepler-438b, but we haven't had official confirmation because we can't yet be sure. What initially sent the internet into something of a frenzy were general reports of one researcher declaring that the signal was likely alien. But elsewhere, the reaction has been a little more conservative. There is one final and unique element of mystery to the FAST signal specifically, though, as the original article that had detailed the newest findings was reportedly found to have quickly disappeared from the internet almost overnight. The news had barely been released, and then it was as though it had never happened at all. This somewhat unusual turn of events has, perhaps unsurprisingly, led some to even further dismiss the entire story as false or in error. Again, with an eye on what the mistaken signals might really be. One SETI researcher, Dan Werthermer, is widely cited, asserting that the signals are, quote, from Earthlings, not from ET. And many other onlookers have agreed, arguing that the apparent removal of the original article also proves that the results must have been misunderstood to begin with, and that really there's nothing at all alien about them. However, this isn't the last word on the matter. Those from FAST who discovered the signal have yet to declare that they were wrong, and still no one knows exactly why the article was deleted. Indeed, another explanation might be that news of experiments and studies is often only made public whenever the peer-reviewed results are available. The initial reaction doesn't always get released, so it could simply be that the original study had been taken down temporarily while the review process is completed. But of course, there's also been some suggestion that there could still be more to the story. Might this, for example, be a case of the authorities hushing up UFO or alien evidence? Was this research actually rescinded because it truly did find something extraordinary and the world just isn't ready for it yet? Whenever there's an element of doubt created, as there has been here, the alternate theories are sure to follow. What's your opinion on the matter? Could there be more to this story than we're currently being told? Ultimately, what we know is that there can be any number of problems when looking for aliens or even just when studying astronomical objects from Earth. For myriad reasons, our view of the skies can be obscured, distorted, and deceiving. And astronomers note that the situation is only going to get worse with the launching of more and more satellites in the future. All of which means that the true origin of any one radio signal is always difficult to determine. For now, researchers are left wondering what the latest results from FAST really mean. Was the original story taken down simply because it got it wrong? Or is there another reason as to why it disappeared? Because that's how scientists may have just discovered a potential alien message. The concept of time for humans has always been somewhat tricky. It seemingly moves in one direction, but many natural laws appear to work backwards in time as well. Time seems to move at a constant rate, too, but we know that in the wider picture, it's actually completely subjective and can change depending on how fast someone is traveling. We still don't fully understand time as a species then, but scientists may have just made another fascinating discovery about it. Because time is such a challenging concept to investigate, many aspects of it are arbitrary. Philosophers often have different concepts of time compared to scientists, and even our standard measurement system of time, made up of seconds, minutes, and hours, is simply how we choose to measure it. It's not as though it has to be that way. Breaking time down into intervals of 60 was first developed by the ancient Babylonians, who inherited their general number system from the Sumerians. Meanwhile, the length of our day is derived from how long our planet sees the sun in the sky, which means that a day as we know it is actually only really specific to Earth. As science has advanced, we've been able to define each unit of time more clearly. For example, the true scientific definition of a second is now how long it takes for a cesium atom to complete a set number of oscillations. This length of time is true time within our own structures for it. Zooming further out, we can view time as the fourth dimension of reality. Objects exist in 3 dimensions of space, but in order for them to experience change in any of those dimensions, time must pass. Space-time was a concept developed by Albert Einstein in the early 1900s to show that all of the dimensions, the 3 space plus time, can be collapsed into a single model that explains how they interact. Until today, that 4-dimensional 4D model has gone largely unchanged. So when physicists announced in July 2022 in the journal Nature that they've essentially created a new theoretical dimension of time, it's no surprise that people took notice. The study was held by a team at the Center for Computational Quantum Physics based in New York, although the experiments were staged in Colorado. And as it turns out, the discovery that was ultimately made wasn't exactly intentional. The team behind it were actually studying how to create a new phase of matter. But in the process, they ended up hosting a new dimension of time as well. At first, to create a new phase of matter, as was their intention, the team completed experiments in quantum mechanics. They wanted to create what's called a topological phase of matter, also known as quantum matter, which uses quantum entanglement patterns to build an all-new product. There's intricate science here, but what it comes down to is that different phases of matter are defined as such because they have what are known as different symmetries. When water is liquid, for example, the atoms within it are random and move around in space to fill empty spots. But when water freezes, it loses that freedom. Its symmetry has changed. The atoms within behave differently, and it has therefore become a new phase of matter. In essence, the breaking of the symmetry of atoms is what signals a change in the phase of matter for anything. But the team behind this latest study found themselves confronted with a further unexpected question. Because what if you broke the symmetry in time instead of in space? Led by the physicist Philip Dumitrescu, the team worked on a quantum computer with qubits in the initial attempts to create their new phase of matter. While regular computers use regular bits, zeros or ones, aka binary, quantum bits, or qubits, can allow something to be either a 1, a 0, or, because of quantum strangeness, both at the same time. This is important because it's this that allows quantum computers to be so much faster than traditional ones. And with the right know-how, it means that qubits could also, theoretically, be used to create that new topological phase of matter as they entangle with other qubits. In simplest terms, it's as though in the quantum world, anything is possible, or at least nothing is guided by standard physics anymore. The problem is, however, quantum particles stop being quantum if they interact with the outside world in any way. And in this sense, they are extremely unstable and short-lived. To make the quantum properties last longer then, and to potentially create matter in this instance, the researchers wanted to stabilize the qubits by adding in time symmetry. Whereas spatial symmetry is just something that's repeated over and over in space, such as the atomic structure of a diamond, time symmetry is such that the individual qubits will always be the same at certain points in time. To accomplish this time symmetry then, the team used a regularly flashing laser. By having the laser pulse continuously at the same interval every time, an apparent dimension of time could be imposed onto the quantum objects, in hopes of stabilizing them. However, as complex as all that sounds, it didn't work. Despite the time symmetry added in, the qubits still barely lasted for more than a second. Their quantum properties almost instantly failed, and no new phase of matter was achieved. But this is where the idea for adding in another extra time symmetry came into play. As next, the team used another additional laser, one that produced a different symmetry, to almost shore up the conditions for their hoped-for quantum matter. By doing so, they were arguably now imposing 2 dimensions of time onto the quantum particles. 2 lasers pulsing at different intervals in a bid, again, to stabilize the qubits into matter. The second laser was pulsed according to the Fibonacci sequence, which is a non-repeating pattern that actually already occurs throughout nature. It can be seen in everything from the arrangement of leaves on a flower to the pattern of pine cones and the shapes of some fruits. Ultimately, by adding in this second Fibonacci time symmetry, the researchers were able to stabilize their qubits for a short time and therefore create the new phase of matter that they had originally sought. The stabilization still only lasted for a few seconds, but nonetheless for significantly longer than any other attempt made before. Most significantly of all, though, because of the additional time symmetry required to make the experiment work, it was as though the new phase of matter also only existed in a new dimension of time. Under ordinary conditions, it hadn't been possible, but by bending time to their will, the team were able to make it happen. So what's next? The study highlights a potential method for increasing quantum stability through dimensions of time. But what does that really translate to in the real non-quantum world? Well, for one, it's said that this breakthrough has the potential to revolutionize and fast-track our general efforts toward quantum computing and information storage. Anything to increase quantum stability or quantum coherence could lead to more viable and less error-prone quantum computing technologies. Currently, fully functioning quantum computers are still considered to be quite a way off, but for the team behind this study and for many watching on, the adding in of an extra time dimension could mark a vital first step along that path. Philip Dumitrescu, in an accompanying statement for the study, refers to the ongoing development of quantum computers as, quote, an open problem we're working on, end quote. It's tipped to become one of the most exciting and important technological advances in the near future, and this study may well have provided the key to unlock the door. As we step over the threshold into the quantum age, there are some predictions that quantum computing could quickly become a trillion-dollar industry. Such is the power and influence that it will hold over society. From chemical research to biological engineering, cybersecurity, encryption, and artificial intelligence, the scope for quantum tech is incredibly wide, even if the specifics are still somewhat ambiguous. The picture is clearing, though, and all it's taken is some major temporal remodeling to push the process forward. When you think about it, science in the 21st century is pretty incredible, because that's how scientists just discovered, or perhaps more accurately, built, a new dimension of time.
Which of these discoveries do you think could have the greatest impact? What are you most excited about when you imagine the future of science?